In this video, we're going to be looking at how to use Gaussian elimination. So right now I have three equations and I have three unknown variables, x, y, and z. Now, we know when we have two unknowns and two equations, we can use either substitution or elimination, and that's by solving simultaneous equations. But when we have three equations, we have a very nice way of doing it, and that's through Gaussian elimination, or another way of saying it is augmented matrices. So the first step I'm going to do is I'm just going to reorder each of these three equations. So I have the coefficient of x going from smallest to largest. And when I say smallest from largest, I mean smallest absolute value. So because this one has 1 as the coefficient, whereas these two have 2, then I'm going to order them in such a way like this. Doesn't really matter how you organize the last two, but it matters that you have the first one as the lowest coefficient of x. The next thing I'm going to do is I'm going to construct a matrix. And my matrix is going to look like this. I'm going to take the coefficients of the x, the y, and the z term of the first equation. So I'm going to take 1 as the coefficient of the x, 2 as the coefficient of y, and minus 2 as the coefficient of z. And we know that this system is equal to 7. So I'm going to do a dashed line like this and write 7. Now I'm going to repeat these steps for the other two equations as well. So what I'm going to do is take the coefficient of the x, and that's 2, coefficient of the y, which is minus 1, and the coefficient of the z, which is 1. And that's equal to minus 7. And lastly, minus 2, 1, 3 equals to minus 1. So that's the first step I'm always going to do. Now, when we do Gaussian elimination, the steps will always be the same, regardless of what numbers you have and what equations you have. So the first step we always do is we try to make this number into a 0. So we try to make the first number in the second row equal to 0. And we can't just do that using any method we want. We must specifically use the first row. Using the first row. We cannot use the third row, only the first row. So let's think about it. What can I do with 1 and 2 to make this value here equal to 0? Well, one thing that I can think of is I can do 2 times the value in row 1. So if I do this times 2, I get 2, minus away the value in the second row, minus row 2. And what that gives me is this value becomes 0, because 2 times row 1, which is 2 times 1, minus the value in row 2, which is 2, equals to 0. And so that's what I'm going to do for all the numbers in row 2 now. So let's write that out. If I were to write out a new matrix and copy down the first row and the last row, all I have to do now is work out the values in the second row. So if I were to do 2 row 1 minus row 2, that would give me the first value as 0. Now if I were to do 2 times 2 minus minus 1, so in other words 2 times 2 plus 1, that would give me 5. So that's the value over here. And for the third entry, we can do 2 times the value in row 1, which is minus 4. And now we're going to minus away the value in the second row, which is 1. And that's minus 5. Now we have to do the same thing with the last value, the answer. So 7 times 2 is 14, minus 7, that's equal to 21. And there we have it. We have our second matrix. The next step we have to do is we have to make the third row, this value, equal to 0. So what we have to do is we have to make the first number in the third row equal to 0. But again, we can't just use any method we want. we have to use row 1. Using row 1 once again. We cannot use row 3 and we cannot use row 2. So now let's have a look. If we were to find a way to make this value equal to 0 using this number here, one way I can think of doing that is 2 lots of row 1 plus row 3. And the reason I'm saying this is because if I were to take 2 times the value in row 1, that would simply be 2 times 1. Then we would do plus row 3. So the value in row 3 is minus 2. And so I'm going to do plus minus 2. And another way of saying this is just 2 take 2, which is 0. So that's why I'm doing 2 row 1 plus row 3. So let's construct a new matrix to demonstrate this new information. So because I'm only modifying the third row, there is no need for me to mess with the first 2 rows. So I'm just going to copy down the numbers that I have in the first 2 rows. Now, I have to do 2 row 1 plus row 3 for each of these entries over here. We know that the first entry has to be 0 because that's the whole reason we're using this equation here. Then for these 2 numbers, if I do 2 times row 1, that would be 4, and then plus the value in the third row, that would be plus 1, which is equal to 5. Next, I'm going to do minus 2 times by 2, which is minus 4, and I'm going to do plus 3, and that would be minus 1. And lastly, I'm going to do 2 times 7, which is 14, and plus minus 1, which is the same thing as 14 minus 1, which is equal to 13. And there you go. Now the last step that I have to do is I have to make either this number here or this number here equal to 0. So what I have to do is make the second or third number in the third row equal to 0. And this time I have to using the second row. And the reason we're using the second row is we don't want to accidentally get rid of this 0 we spent so long trying to get. So I need to find a way to make either this number here or this number here equal to 0. And personally, I would make this number here equal to 0, this second entry, because I can simply do 5 minus 5, and that's equal to 0. Or another way of writing that is row 2 minus row 3. So let's have a go at doing this now. We're going to construct another matrix, and this time we're going to copy out each of the unaffected rows. So that would be the first row and the second row. Now let's work on the last row. Because we're doing row 2 take row 3, all we have to do is take the number above and minus it from the number below. And we know that 0 minus 0 is simply 0, so I'm going to write that there. And notice we didn't change this number here, that's why we used the second row. Now we're going to do 5 minus 5, and that is equal to 0. Minus 5 minus minus 1, that's the same as minus 5 plus 1, and that means this would be minus 4. And 21 minus 13, that would be 8. And there you go. This is my final matrix, and the name of this matrix here is a matrix in echelon form. And what echelon form exactly means is we just have a row of zeros in a triangle like this. If you see 3 zeros like that in a matrix, that just means it's in echelon form. So what's the significance of this matrix now? Well, if I wanted to solve my original 3 equations, what I've really just done is I've constructed 3 new equations based on the coefficients of my original ones. So what I can say is, using the last equation, I can say that minus 4z equals to 8. And the reason it's minus 4z is because all these numbers that we have on our matrix were simply the coefficients. They were the coefficients of our original equations. And that's why we're able to say that minus 4z is equal to 8, because the 0x plus 0y is the same thing as just 0. So now I can solve for my first variable. Z equals to minus 2. Next, I can use my second equation that I have in the second row. I can construct an equation by saying that 0x plus 5y minus 5z equals to 21. And we know that 0x is the same thing as just 0. And we know we just worked out what z was. So I'm going to substitute what we just worked out for z. Now that I have it looking like this, I can say that 5y plus 10 equals to 21. And all that simply means is 5y equals to 11. That means that y equals to 11 over 5. Lastly, I can use the equation in row 1. I can use the equation in row 1, and I can say that x plus 2y minus 2z equals to 7. We just worked out x and y. So let's give that a go. X plus 2 times 11 over 5 minus 2 times minus 2 equals to 7. That means that x plus 22 over 5 plus 4 equals to 7. That means that x equals to 3 minus 22 over 5, and that means that x equals to minus 7 over 5. And those are the solutions to the original three equations we had. X equals to this, y equals to this, and z equals to this. So that's how we solve three equations simultaneously using Gaussian elimination. Now let's have a look at another example. We have three equations with three unknown variables, and we're going to use Gaussian elimination again. Pause the video to give this a go. What is the value of x, y, and z using Gaussian elimination? The first step is we need to organize these three equations so that the coefficients of each of the x terms are in ascending order. So what I'm going to do is I'm just going to swap the last two equations just so I have it in ascending order. Now it's going from 1 to 1 to 2. I want to construct a matrix now using the coefficients of each of these values. So the coefficient of x in the first equation is 1, coefficient of y is also 1, and the coefficient of z is minus 3. And the answer to this equation is 6. In the second row, the coefficient of x is 1, the coefficient of y is minus 2, and the coefficient of z is 1. And the answer to this is minus 6. And the coefficient of x in the last row is 2, the coefficient of y is 3, and the coefficient of z is 2. And the answer is 2. So the first step I have to do is I have to attempt to make this number equal to 0 using the number in the first row. And I can simply see that 1 minus 1 equals to 0. So I'm just going to write this as row 1 minus row 2. That is the operation I'm going to do to this matrix. Now, if I were to write a new matrix, I can see that because I'm augmenting this value in the second row, I can just write my first and third rows completely unaffected. Okay, so now let's do our operation. We have to take the value in the first row and minus it from the value in the second row. So 1 minus 1, that would simply be 0. 1 minus minus 2, that's 1 plus 2, and that would simply be 3. And then minus 3 minus 1, that's minus 4. And 6 minus minus 6, that's the same as 6 plus 6, which is 12. Next, my goal is to make the first number in the third row equal to 0. And we're going to use the numbers in the first row. So one way I can make this number equal to 0 is I can times the first row by 2 and then minus it from the last row. because 2 times 1 minus 2, that's the same as 2 minus 2, which is equal to 0. And so that's what I'm going to do. I'm going to do 2 times row 1 minus row 2. And we're going to draw another matrix with this time the first 2 rows being unaffected. So if we do 2 row 1 minus row 2, the values we should be getting are 0 in the first row, then 2 minus 3, which is minus 1, then minus 6 minus 2, which is minus 8, and 12 minus 2, which is 10. Lastly, I can choose to make either this number here or this number here into a 0, depending on whichever one is easier. So I'm going to make the third entry equal to 0, and the way I have to make the third entry equal to 0 is I'm simply going to use the second row. And it doesn't matter which one you make equal to 0, but just to spice things up, I'm going to make the third entry. And the way I'm going to make the third entry equal to 0 is by doing 2 times the row 2 minus row 3. And if we do this, we know that 2 times minus 4 minus minus 8 is the same thing as minus 8 plus 8, which is equal to 0. So let's construct one last Gaussian elimination. So now we're going to do the Gaussian elimination. So what we're going to do is we are going to do 2 row 2 minus row 3. And 0 minus 0, no matter what we times it by, is always going to be 0. 2 times 3 is 6. Minus minus 1 is 7. 2 times minus 4 is minus 8. Minus minus 8 is plus 8, which is 0. 2 times 12 is 24. Minus 10 is 14. And there we have it. We have our matrix in echelon form. This one looks a little bit different, but it's still echelon form as we have 2 zeros on the last row. So this is another form of echelon. So now let's see what this really means. We know that the number in the second column is going to be the coefficient of y. So using this last row, I can generate an equation that says 0x plus 7y plus 0z equals to 14. And we know that 0 times anything is simply going to be 0. So all we really have is 7y equals to 14. And that means y equals to 2. We've already solved for our first variable. Next, I'm going to use the values in the second row. And I can skip this 0, and I can simply say that 3y minus 4z equals to 12. And we just worked out y. So we can say that 3 times 2 minus 4z equals to 12. That means that 6 minus 4z equals to 12. That means that 4z equals to minus 6. And that means that z equals to minus 3 over 2. And lastly, I can use my first row to solve for x. And I'm going to generate an equation that says x plus y minus 3z equals to 6. I just worked out what y and z were, so I can say that x plus 2 minus 3 times minus 3 over 2 equals to 6. X plus 2 plus 9 over 2 equals to 6. That means that x equals to 4 minus 9 over 2, and that means that x equals to minus a half. And those are my values for x, y, and z.